our next speaker, JeanYves Stephan. JeanYves was one of the early software engineers at Databricks, and now he is the co-founder and COO at Data Mechanics, a Y Combinator startup. Data Mechanics is a cloud-native Spark platform for data engineers available on AWS, GCP, and Azure. Their mission is to make Spark a lot more developer-friendly and cost-effective than alternatives. In this talk, he will tell you more about the benefits of running Spark on top of Kubernetes and why this integration was recently declared generally available.
Thanks.
Welcome, JY, and the stage is yours.
Yes, thanks so much, Elena, for this lovely introduction, and thank you all for attending Data Love. Elena pretty much said it. I want to talk today about cloud-native Apache Spark, running Spark on Kubernetes, and the fact that Spark on Kubernetes is since March officially generally available. So first, just a few words about me. I used to work as a software engineer at Databricks, and now I'm the co-founder of Data Mechanics. We are a Y Combinator startup. This was our team some time ago. And our goal, Data Mechanics, is to make Spark a lot more developer-friendly and cost-effective for data engineers mostly. And our platform is deployed on top of a Kubernetes cluster inside our customer's cloud account. So that is why we have learned Spark on Kubernetes, the ins and outs of it, and that's why I'm giving this talk today. This will not be a marketing talk. It's going to be a pretty technical talk. I hope you're going to learn lots of interesting things about Spark on Kubernetes and concrete tips to help you adopt it if that's your goal. So this is my high-level agenda for today. First, an introduction about the core concepts of Spark and Kubernetes, then explain why do more and more companies choose to adopt it, and go over a specific example of a customer who migrated to it and the benefits they got. Then I will give some concrete tips and advices to help you migrate to Spark on Kubernetes. And last but not least, we'll talk about the latest release, Spark 3.1, which declared Spark on Kubernetes generally available and production ready. So first, before I talk about Spark on Kubernetes, what is Spark? So it is a distributed analytics engine that can process very large volumes of data. It has API in Python, Scala, Java, SQL. And one of the things that people like about this tool is that it's pretty versatile. So you can do business intelligence, you can do data science and machine learning, and then obviously you can do data engineering, whether it's in a batch way or whether it's real-time streaming. So the power of Spark is that it can take some pretty simple code and then distribute it on tasks which are going to be executed in parallel on a cluster, so on a collection of machines. What Kubernetes doesn't do is actually manage those machines. Okay, for that it needs a cluster manager. Before Kubernetes, the main cluster managers were standalone mode, Mesos, and mostly Hadoop Yarn. Hadoop Yarn was the most used cluster manager for Spark. And now since 2018, you can run Spark on top of Kubernetes. And let's go over the high-level architecture of what that means. So when you start a Spark application on Kubernetes, you can talk directly to the Kubernetes master, so the Kubernetes API server, which is going to understand your request, and it's going to start a driver pod. A pod is basically a container, to put it simply. Then the Spark driver is going to talk back to the Kubernetes master to request executor pods. So the driver is the process that understands your code, and the executors, that you have many of them, they're the processes that do the real work. And so the Spark driver and the Kubernetes master are going to be directly talking to each other, and that's how more executor containers are going to be started. And once they're up, the driver is going to run tasks on them. Here I mentioned Spark Submit, but a slightly I'll go back to the previous slide after, but the slightly more popular way of running Spark on Kubernetes is using what's called the Spark on Kubernetes operator, which is an open source project and which basically lets you run and manage Spark applications just like if they were a regular Kubernetes object. So you can start them with a YAML file. You have some toolings to read their logs. You have some tooling to kill an application, restart it, schedule it. It provides some syntactic sugar. So honestly, I would recommend it. The only downside is, it is one dependency that you need to install, and there will be a long-running pod on your Kubernetes cluster. Going back to the previous slide, what are some of the differences with Yarn? Well, with Kubernetes, you typically have a single Kubernetes cluster, and all your applications run on it because they're going to be isolated. They're going to be run in separate Docker containers, and each Spark application could be using a different Spark version. You could have notebooks and batch jobs and streaming applications running all at the same time without ever interfering with each other. And you can also use, if you talk about the underlying infrastructure, you can be using a mix of different instance types, a mix of spot and on-demand nodes, and so on. And the cluster typically is long-lived, so you don't necessarily fully tear it down, but what you will do is you will scale it down to a size of almost 0 when there is no load, and then automatically scale it up based on load. So now, why do more and more companies choose Kubernetes? Is that just a buzzword, or are there some real tangible benefits? So one benefit is containerization. I just mentioned it. When you run Spark on Kubernetes, it runs in a Docker container, and you have control as a user on the Docker image. So what that means is that you can pick your Spark version, your Python version, your Java, Scala, Hadoop, whatever version independently, and that's going to save you from dependency nightmares where, someone else upgraded Spark or upgraded Hadoop, and then your application broke. It will make your code more reliable, and it also speed up your iteration cycle because Docker containers are really lightweight. And so in really 30 seconds, you can go from making a change on your code locally and having it run at scale on the Kubernetes cluster. And obviously, you can run it anywhere. You can even run it on your laptop, which is a popular option for development and testing. The other benefit is you have a shared infrastructure. As I said, you have a single Kubernetes cluster, and all your applications can run on it in a fully isolated way. So you get the benefit of full isolation as if everyone had their own little cluster, but actually the underlying infrastructure is shared. And so you get fast application startup time. You can quickly rebalance load across the cluster. And overall, this means that you get a lot of cost efficiency. And we'll see later some examples of customers who have reduced their cost by a lot by migrating to Kubernetes. Last advantage is that Kubernetes is a very popular ecosystem, and so you get a lot of tooling for free. First, it is a cloud provider abstraction. Okay, so if you run your application on Kubernetes, it's easy to migrate to another cloud or maybe even on-premise. Then you get some CI/CD tools. You have some logging and monitoring tools, networking, security, you name it. So what this means is that you won't have to have a completely separate stack just for big data. You can start using the same tools as the rest of your company. Now let's go just about one slide about an example customer who migrated from EMR to Spark on Kubernetes. This customer is called link.io. They're a Spark-based data integration platform. They used to run on EMR, which is Amazon managed Spark and which uses Yarn. And their pain points was that EMR infrastructure was hard to manage. It was hard. It was a lot of work. It was hard to keep your application stable and cost effective. Also, the Spark application didn't start very fast, and this was wait time for the end user of Link in their product. And they were somewhat stuck with an older version of Spark. They had tried upgrading, but upgrading the entire cluster one at a time would cause havoc. So when we migrated them to Spark on Kubernetes inside our platform, we got some pretty impressive results. We reduced their AWS cost by 2/3. We reduced their application startup time by half, and their overall average app duration was also decreased by something like 35%. Mostly it's due to Spark on Kubernetes, the fact that we have the single shared infrastructure. There were also some optimizations that we added on top, data mechanics. Great. So now that we covered, I think, a high-level introduction of Spark on Kubernetes, I want to give you some concrete best practices and advices to migrate to Spark on Kubernetes. So the first one is around infrastructure management. I said it earlier, that the Kubernetes cluster should not have a fixed size. Okay, that's not an efficient way, not a cost-efficient way to manage your infrastructure. So what you should do is define multiple auto-scaling node pool. So a node pool is a pool of virtual machines. So you could have, for example, one node pool which uses M5X large instance and which is on demand, and then you could have another node pool which uses R5X large instance and which is on spot, and another M5X large on spot, and so on. And then these node pools, you will configure them such that they can automatically scale up and down based on the load. I cannot here explain the full details of that configuration, but we use an open source project called Cluster Autoscaler. And to manage spot and on demand, there are some additional complexities, but I'll put a link in the slide and I'll send them to the Slack channel afterwards. What you can see then is that what you get is you may decide to put the Spark driver on on-demand nodes. That's generally a better choice. You don't want to lose your Spark driver because of a spot kill. But then the executors on spot, and basically as, let's say, one Spark application decides to add more executors, well, automatically the kube cluster will scale up and add more nodes to it. And then vice versa, when the node is idle, it will give the resource back to the cloud provider. One trick here that we like to use with many of our customers is that if you have some capacity available on the cluster, starting a container takes less than 10 seconds. And for some customers like Link, they really care about that. So what we did is we enabled some over-provisioning. What that means is that we will always try to maintain a little bit of additional capacity on the cluster. We do this by defining what we call pause pods, which is basically a pod that does nothing and that has a very low priority, such that when, let's say, a Spark application requests a new pod, well, Kubernetes is going to say, this low priority pod, I'm going to kill it and I'm going to use the space for another application. And so that means that your pod starts immediately in less than 10 seconds. And then Kubernetes is still going to say, okay, I need to get a new node to actually put this pause pod. And so it's going to request a node from the cloud provider. And in 1 to 2 minutes, the pause pod will be there again. So it's really, for a very little additional cost, you're going to get great experience, particularly if you're using Spark in an interactive way, for notebooks and so on. So far we were talking about the Kubernetes cluster automatically scaling, so the adding nodes, adding VMs. But within a Spark application, so if I go back, if we look at the blue application, right now it has one driver and 3 executors, but the number of executors can also dynamically scale up and down while the application is running. We call that dynamic allocation, and it's available on Kubernetes since Spark 3.0. You need to turn on 2 configurations to make it work. The first one is the typical one that you always turn on, and the second one is specific to Kubernetes, because to make dynamic allocation work, there is a mechanism called shuffle tracking, where when you want to downscale with dynamic allocation, the Spark driver is going to make sure that you don't downscale the container that contains shuffle files, because if you do, you would lose precious data that will be needed downstream. So dynamic allocation with shuffle tracking works really well. We really recommend it, particularly when you use Spark with notebooks, because with notebooks you tend to use the notebook for 10 minutes and then maybe go to a 1 hour break because you have a meeting. And so what that means is that the notebook will do its work, and then automatically once it's done, it will scale back down to 0. So on data mechanics, we typically enable dynamic allocation by default. So we talked a bit about infrastructure management, how to properly size your cluster and your executors and so on. Now let's talk a bit about Docker images, because I told you earlier, you have control over the Docker image. This being said, it's not easy to build the Docker image that exactly suits your need. And to make things a little bit easier, we have just open sourced a fleet of Docker images that we were already building and maintaining for our customers. And they come built in with a lot of dependencies. So obviously the Docker image is Spark, but it also has Python, Java, Scala. And if you go to our Docker Hub, you'll be able to pick, I want Spark 3.1, and I want Python 3.8, and I want Scala 2.12, and so on. And on top of this, we also include a set of connectors to the popular data sources. So typically Google GCS, Amazon S3, Azure Data Lake, V1, V2. We also support Delta Lake. We also support Hadoop, and we also support Snowflake. And I think we will be, we will keep adding more connectors to it, fixing bugs when they come up. So our hope with this project is that it will just work out of the box for you. Maybe a last best practice and advice is around monitoring. So how do you keep track of what's happening and troubleshoot when you have an issue? You have two types of tools. You have general purpose monitoring tools for Kubernetes. An example one is the Kubernetes dashboard, which is pretty easy to install. So what's great is you will have some CPU and memory metrics, but it will be at a pod granularity. So then it's up to you to figure out, this is the Spark app and this is the executor pod, and so I want to. You have to do a bit of work. It's hard to reconcile this data with the Spark information. If you want something more Spark specific, obviously you have the Spark UI. And for that, while the application is running, you can just port forward, so basically access a given port on the driver pod, and then that will give you the traditional Spark UI. The only problem with it is, it's not super user-friendly, and you typically don't have the metrics I was mentioning earlier, like memory, CPU, I/O, disk usage, and so on. So to try to go a step further in terms of monitoring, we have built a tool internally for our customers, and we are now opening up this tool also to the world. So it's called Delight. It's a free and cross-platform Spark UI complement. And what you get in Delight is that on a single graph, you can see CPU metrics and memory metrics aligned with a timeline of your Spark phases. So you can, for example, correlate and say, in this first part of my code, I was reading a lot of data, and so my CPU are mostly doing I/O. Or, in this part of my code, I was doing a shuffle. I was sending a lot of data around, and so it can be seen on the CPU plot. And our goal with Delight is to make it easy to troubleshoot performance issues, to figure out what's the bottleneck, and also to fix instability, out of memory, why, and so on. So it works using an open source listener. So the open source listener is on GitHub. This listener, you can attach it to your Spark application. This works on Kubernetes, but this also works if you're just using Spark open source, if you're using Spark on Databricks or Amazon EMR or Google Dataproc, whatever. It just plugs in using the Spark listener. And then this listener is going to stream some metrics from your Spark application to our backend. They will be encrypted, they will be secured, only accessible to you using a Google single sign-on. And basically, these metrics will become available to you Right now, they're not available live. You have to wait until the app is finished. So it's more like a history server than a live Spark UI, but we're going to keep working to make it live. And in addition to the Spark, to the Delight, you also have access to the Spark UI. So if for some reason you don't have a simple access to a Spark history server, you could just use this tool, and that will also do it for you. Here's an example of a customer who made a huge performance impact thanks to the screenshots from Delight. So on the left, you had their application before an optimization, and their app would run in 4 hours, 20 minutes. And from the Spark UI, it wasn't obvious what was the problem, but from Delight, it was obvious that most of the job was spent doing shuffle, so sending data within the cluster. After optimization, this app now runs in 25 minutes. So we made a 10x improvement by using the same instances, number of executors, etc. So how did we do that? We basically attached local SSDs. So these are a type of disks that have a very fast bandwidth, and that's very important for shuffle because when you send data within your cluster, the data is first written to the disk and then it is pulled by another executor. And typically, disk I/O is very often the bottleneck. And so in this case, by adding these faster disks, we enabled a 10x speed up. So yeah, I hope Delight will be useful to you. Last topic I wanted to cover is the fact that Spark on Kubernetes has been officially declared generally available and production ready since Spark 3.1 release in March. So first, let's take a step back and look at the Spark on Kubernetes journey. So in February 2018, initial support started with Spark 2.3, but honestly, it was not very stable. It was spearheaded by a handful of large enterprise companies, but many critical features were missing. But the community started adopting it and started contributing to it like crazy. And just later the same year, when Spark 2.4 came out, you had crucial new fixes and features like volume mounts, like PySpark and R support, or like the ability to run Spark in client mode. Then we had a year and a half gap until Spark 3.0 was released, and Spark 3.0 brought the critical dynamic allocation improvement to Spark on Kubernetes. And then that brings us to this year, last month, when Spark 3.1 was released and Spark on Kubernetes was officially declared as generally available. There were a few critical features that I'm going to explain now. So the first one is called better handling for node shutdown, or it's also called graceful decommissioning. What does that mean? It means that let's say that you put the Spark executors on spot nodes, which is a great way to save costs. Right now, if you do that, when you get the spot kill, you obviously lose the work you were doing, and you also lose the shuffle files which were sitting on this node. And shuffle files, they are basically the output of work that you did in the past. So when you lose it, it's pretty frustrating. It means you're going to need to recompute that work to reproduce the shuffle files elsewhere. So with this feature, the cloud provider is going to give a notice. I mean, they already do that, but Spark is going to be able to listen to the notice of the cloud provider and use the 2-minute notice that the cloud provider gives to automatically move shuffle files around. So let's look maybe at the example through the slides. First, you get the warning of the node shutdown from one of the cloud provider. Then automatically, first, the driver stops scheduling tasks on this executor because it knows that the executor is going away. And more importantly, it's going to move shuffle and cache data from this executor who's going away to an executor who's staying. And so as a result, when the spot kill effectively occurs, your shuffle files have been saved here and your Spark application can continue with very minimal impact. So this is really, really powerful. I think this is one of the biggest improvements in terms of running Spark in the cloud for maybe since dynamic allocation. I should also say that this happens indeed when a spot node is interrupted, but it also happens during dynamic allocation. So when you just want to remove an executor, and because the executor is idle, but the executor is storing important shuffle files, well, you can move these shuffle files to another executor. So that's another big improvement. Another feature I wanted to mention is the ability to mount a shared NFS volume on your Spark applications. NFS is a technology that should really simplify collaboration and maybe the development workflow within the company, because basically the volume that you're going to mount is going to be shared across all your Spark applications. So you could put, I don't know, shared libraries, you could put some data in there. It's not really handled to designed to be performant with large scale data, but for small data, for libraries, for code, it's great. And this is something that's now much simpler since Spark 3.1. I think this is it. I have a few minutes in case I could see a question, but I think we will actually do the question in the spatial chat afterwards. So actually, I may use the 3 minutes we have to just show you a very quick demo of running Spark on Kubernetes. What I'll do is I'm gonna show you here a Docker file. So here I have a little PySpark project, and this is a Docker file, so an instruction to build a Docker image. And then I have a script that is going to build a Docker image using this Docker file, then push my Docker image to a Docker registry that I own, and then make an API call to run this application on the Kubernetes cluster managed by Data Mechanics. So let's see, I think here we go. So I have a one-liner command, just run cluster. And now we're building the Docker image. Then we're pushing it to the registry. And then we're going to make the API call to actually run this at scale. And I want to show you that you can have a fast iteration cycle working this way. So as you can see, the Docker image has been built and pushed really quickly. And now the app is already running. So I think in less than 30 seconds, we went from making a change to my code. I didn't show you the code, but it's not that interesting, to having the new application run at scale. And I'm just going to show you on our web dashboard the kind of monitoring that we give you here at Data Mechanics. So this is the application that I was running. It actually just completed. It was a pretty short application. If I click here, I can see the full configuration that I was using. So you could see, for example, that I did enable dynamic allocation. You can see the configurations that the Spark driver pod was using. You can see the configuration that the executor pods were using. And down here, you have access to the driver logs. So this is pretty easy if you want to troubleshoot. You have access to the Spark UI, both while the app is running and also after the fact once the app has completed. Here it says not found just because the app has just finished, and so it's not yet available in the Spark history server, but I'm sure that in a minute or two it will be there. And you also have access to a few high-level statistics about your application. And here it's not that interesting because it was a very small, hello world application. But this is one way that you could be tracking your cost, that you could be tracking how much data each application reads and writes. And you find this information also over time. So if you start, running a pipeline on a schedule, you could be checking this over time. And finding the same metrics like how much data am I reading and so on. And yeah, I think we're almost over time. So I want to thank you all. Also just wanted to show you what the Delight UI looks like. And I'll now head out to the spatial chat to meet you and do some Q&A. Thank you.